4 complex numbers. So this lesson's all about a new set of numbers that we're going to talk about that are very important. So let's just get into it. First, let's talk about what an imaginary number is. So if you remember in general, we used to go, hey, what's the square root of -4? And you're like, can't do it. Can't take the square root of a negative number. Well, that's out now. Now we're going to say this. Square root of -1 is this number I. So from now on, square root of -1 is I. When we get a number like square root of -81, we could write this. It's the same thing as saying square root of -1 times 81, right? Just split it up. And if we break it up, it's square root of -1 times square root of 81. Square root of -1, that's from now on, it's going to be I. Square root of 81, 9. So this is 9I. Now that's a long way to do. I don't expect you to do it like that every single time, or ever actually. What we're going to do is this. We're going to, hey, there's a negative inside the square root. We're going to pull that out. So that's going to be an I. Right, 81. And then square root of 81 is 9, so it says 9I. So that's how we're going to do it, like here. Oh, square root of a negative, that's an I. I'm going to pull that out. That's I rad 18. Now 18 we could break down. That is what? 2 times 9. Then we could go 9 is 3 times 3. Remember, square root, you need a pair, so that comes out. Is this same thing as saying 3I rad 2? You'd like to put the I in front of the radical, because otherwise we're not, like if I did this, like is that I inside the radical, is it not? It's just confusing. So we always put the I outside the radical. Next one, oh, there's a negative there. Again, we just pull it out. There's the I, rad 125. Let's break down 125. That's 5 times 25. Square root of 25 is 5, so that's going to come out. So I get 5I rad 5. So that's all. So now we can simplify negative radicals. So we're not going to say you can't do that anymore. We're never going to say, hey, this is 2I. So anytime we're negative underneath the radical, you just pull it out and it's an I. Okay, next part. So I'm going to go back up to here. Right? So I is square root of -1. And we always go this way. You never rewrite I as square root of -1. You always just go, hey, if I have that, I'll write it as an I. What if I give you I squared? Well, that's the square root of -1 squared. So these cancel out, you just get -1. So that's another big result. I squared is -1. And I should never see an I squared. Every time you have an I squared, you gotta change it to -1. So you should never see a square root of -1. You should always say an I, but you should never see an I squared. If it's I squared, you change it to -1. So look at this one right here. 2I times 5I. That's 10I squared. Ah, but there's an I squared. That's -1. -1 times 10. -10. That's how that works. Like here. 4I times -3I. That's -12I squared. Well, this is -1. You multiply -12 times -1 is just 12. So that's how you simplify i's. Let's do another one right here. So here, remember radicals. Now, mostly we're gonna before we multiply, because I don't want to multiply -24 instead of -18. I'm gonna simplify each one. 24 is what? 2 times 12, and that is 2 times 6. That's 2 times 3. So a pair of 2's, that comes out. Now, if there's already a number outside, you just multiply. So it's me 6. There's a negative, so let's make that I. And what's left over? 2 times 3, which is 6. So that's how you break down, right? That's how you prime factor and break down. Sitting over here, that's 2 times 9. Well, I know the square root of 9. That says 3, so I'm pull that out to be 3. So 3 times 2 is 6. There's a negative, so I'll make that I. And the only thing that's left over is rad 2. So this problem is just saying 6I rad 6 times 6I rad 2. Multiply them together, and I'm going to get, you always multiply outside by the outside, 36 I squared. Multiply the inside by the inside, radical 12. I squared is -1, so I get -36 rad 12. Almost done. Rad 12 I could break down. 3 times 4, and the square root of 4 is 2. So you multiply and you get -72 rad 3. Oh, isn't math great? So that's our answer. Through all that, you get -72 rad 3. Okay, so we got that. Let's move on. This is one of my favorite things. So let's do a little recap, right? I is square root -1. Again, we always go this way though. I squared is negative 1. You square that. How about I cubed? Well, let's look at it over here. I'm going to erase this in a bit, but I cubed is the same thing as saying I times I times I. Well, what happens here? You get I squared. I squared is negative 1, so negative 1 times I. It's the same thing as saying negative I. And if I do I to the 4th, we could do the same way. Instead of I cubed is I to the 4th. What happens? You get I squared times I squared. I squared is negative 1. I squared is negative 1. You just get I. 1. Like, where am I going with this? I know that last one's a little confusing. Where I'm going with this is this. So, I to the 1st. Let's erase this. Alright, I to the 1st is I. I squared is negative 1. I cubed is negative I. I to the 4th is 1. There's actually one thing I forgot to put here. What's I to the 0 power? I need to erase some more. Man, I'll have space. Wish I had more space in this thing. What's I to the 0 power? I to the 0 power is the same thing as anything to the 0 power, which is 1. Anything to the 0 power is 1 except for 0. So if you notice, I to the 1st is 1, I to the 0 power is 1, I to the 1st is I squared is negative 1, I cubed is negative I, and I to the 4th just repeats itself. That's all that's going to happen. I to the 5th is going to be I. All that's going to happen is you keep on repeating yourself. There's only 4 different possibilities for I. It's called a cyclic number. It repeats itself. So what we're going to do is this. If I get something crazy like I to the 40th, it can only be one of these 4 options. So what you do is you divide the power by 4. There's only 4 options. And look at the remainder. So let me, for example, let's do this one. We'll do a few of these. So I to the 40, I'm going to look at the power and go, okay, 40 divided by 4, and I get 10 remainder 0. So this one, it goes around 10 times and ends up right here, remainder 0. So I to the 40th, the same thing as just saying I to the 0 power, which is 1. So I to the 40th is 1. Look at this one right here. I to the 63rd, so we're going to divide that by 4. 63 goes into 4, I think it goes in there about 15 times. So 15 remainder 3. Right, 63, 4, it's 1, 4, 23, 5, 20, remainder 3. So again, this problem is the same thing as just saying I to the 3rd power. They're equivalent, because it goes around 4 times plus an extra 3. So this is the same as saying negative I. And that's the idea. If you want to find I to any power, since you know there's only 4 options, you just divide the power by 4, no matter what I give you. So, one last example. Let's go let's keep it smaller this time. We'll go 16, 18. 16 is too easy. I to the 18. Divide that by 4. That's going to be 4 remainder 2. So this is the same as just saying I to the I squared, which is negative 1. So that's how you do I to any power. You just divide it, since there's only 4 options, you just divide it by 4 and then see which one it is. Okay, so let's do this a little easier. So we have complex numbers. So back in like chapter 1, we talked about there's real numbers, which is every number we saw. And then when we broke that down, you had 2 options. You had rational, which are fractions, and you had irrational, which are stuff like pi and rad3. And then from there you can break down to like integers, whole numbers, natural numbers, blah, 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 blah. That's all we had. That was our whole world. Now, we just learned an equivalent world of imaginary numbers. Where you can take any number you have in here, like a rational number, like let's say 3/5, and I can make it imaginary. Just add I to it. Boom, it's imaginary. You can take an irrational number like pi, and make that, oof, that's ugly pi. There you go. Make it imaginary by just adding an I to it. Now it's an imaginary number. So imaginary numbers are just as big as real numbers. They're like the same size. You get any number over here, a natural number like 3, put an I on it, boom, it's imaginary. Right, so these are the exact same size. All imaginary numbers, the real number with an I next to it. Above both of these though, we have the top of all the mountains, the king of the hill, which is complex numbers. What are complex numbers? Well, they're a combination of both of these. So like, you get a number like 3, that's a real number. There's no I there, so it must be real. You get a number like 2i, well, there's an I there, it has to be imaginary. It can't be real. Complex is a combination of the two. It's like a number like, they like to say a plus bi. Complex number is like 3 plus 2i. Because it's both real, so it can't be imaginary, and it has an imaginary part, so it can't be real. It's a combination. That's a complex number. Keep in mind though, every number is complex. If I gave you the number like we gave here, 3, like, oh, that's real. It's not imaginary. But you can also write this, and now it's a complex. Same thing with the imaginary number, you write this, and now it's complex. So every number is complex. So just keep that in mind. The biggest number, so this is the top of the hill. The biggest number there possibly is a complex number. Below that there's real and imaginary. They're the same things because you just put an I on it and it's real. Take out the I, it's imaginary. I said it the wrong way. Add an I to it, it's imaginary. Take out the I, it's real. Okay, that's the correct way of saying it. But that's the idea here. So all we're going to do here is add complex numbers. Look at all these beautiful complex numbers. Right? These are complex. They have both an I and a non-I, a real and a non-real part. So we just want to add them. What you do is just add up like terms. You add the real parts together, -3, and then you add the imaginary parts together. 5 minus 3i is 2i. And there you go. Right? It's just like adding variables. Like, oh, I'll just add the x's together and get 5x plus 4y. Exact same idea. Like, oh, let me distribute the negative because I'm not lazy. And all you do is add the corresponding parts. Oh, there's the i's. Let's add those up. Positive 2i. I did it the wrong way. I should add the numbers up first. So you get 8. Oof, that's embarrassing. 6. And then 4 minus 2i is plus 2i. Now we generally want to put complex numbers in the form a plus bi. So you want the real part first and then the imaginary part, but it's the same thing either way. But for proper notation, it's real and imaginary. And then we're going to distribute. So all we do here is distribute, like we always do. Multiply that 6 by both of them. So you get 6 times 9 is 54. 6 times 2i is this 12i. Then we move on and multiply the next number by both of them. So -8i times 9 is -72i. Then right here we got to watch out. -8 times 2i, -8i times 2i is -16i squared. Remember, I squared is special, it's -1. So what happens here is this becomes a positive 16. I see some people add them. I don't know why. No, it's not -17. You're multiplying them. This times this, so positive 16. This is a 54. You can add up the i's in the middle and get -60. And then we can add up the like terms and get 70. And that's how you distribute with the i's. That's how you distribute complex numbers. Let's do another one. Right here, a little quicker. So I'm going to multiply 3 by both, so -6 plus 12i. Then we'll multiply 2i by both, so -4i. Then here I get positive 8i squared. Keep in mind this, sorry, not that. This right here is -1. So that becomes a -8, right? Because you multiply. I should never say an I squared in your answer. I's, yes. I squared, no. These two, you add them up, you get 8i. That's -6. Add these up, you get -14 plus 8i. So that's how you simplify basic complex numbers. So next, let's talk about complex conjugates. That's actually something, that's not something that, there's actually one thing I really care about in this little part right here. That's conjugates. But let's set it up first. So if you remember back in like Algebra 1, they didn't like it when you had, the establishment didn't like when you had radicals in the denominator. So you had to like rationalize it by multiplying by radical 2. So you get 3 rad 2 over 2. Right, so this is called rationalization. Now the thing is, honestly, I don't care about this anymore. A, P, I, B, D, I don't really care. This is a fine answer. You don't need to rationalize it to be like that. But the same thing goes on with i's. If you have something like 3 over 2i, you're supposed to rationalize it. The way we do that is we multiply it by itself. And then you get 6i over 4i squared. Well, see that I squared makes it a negative 1. So I get 6i over negative 4, also known as negative 3i over 2. Right, so it's kind of the same idea how you're not supposed to have this in the denominator. So that's how you rationalize an imaginary number. It's the same idea. Now again, I honestly don't even care. Like, that's fine for me. I being AP would take that as an answer. But there is one thing about this when we get to conjugates that I talk about that I actually do care about. And I will give you some practice problems to do it. Anyway, let's do this into practice real quick. So I have this, I'm going to multiply both top and bottom by 5i. You actually just multiply by I if you want, but let's keep it easy. Distribute, you get 20i plus 5i squared all over multiply 25i squared. This becomes negative 1, this becomes negative 1, and I get 20i minus 5 over negative 25. Now I could simplify this. They're all divisible by 5, so divide everything by 5, you get 4i minus 1 over negative 5. And that's the answer. Alright, so if you have an I on the bottom, you just multiply both top and bottom by it. Just like you did with rational roots. But what if I give you something like this? This is the only thing I care about, because on this thing we need the conjugate. But let me explain why. Let's do what we did before. Let's multiply both by 5i, 5i. On top you're going to get negative 10i squared. On the bottom you're going to get this. 15i plus 25i squared, negative 1, negative 1, 10i over 15i minus 25. You see the problem here? That's still there. So that doesn't solve a thing. So stuff like this where there's a binomial on the bottom, we gotta do what is multiply by what we call the conjugate. And this is the thing I care about because it's actually a very important tactic in mathematics. What a conjugate is this. Think about a difference of two squares. Right, so in difference of two squares when you factor you get a minus b, a plus b. These two right here are conjugates of each other. Because what we want to do is get this a squared minus b squared. So if you have this part, a minus b, what you do is multiply both top and bottom by a plus b. And then that way you can get the difference of two squares. And vice versa, if you have this, you multiply both top and bottom by a minus b, and that way you get the difference of two squares. And that's what we're going to do on this problem right here. Let me erase all this. Let's multiply this by the conjugate instead. So I want to get rid of this thing, so multiply the conjugate at the bottom. So all we're going to do is change the middle sign. That's what makes it a conjugate. So 3 minus 5i. 3 minus 5i. On the bottom, it's the difference of two squares. You can multiply it out if you're not sure. Just do all that. You get 9 minus 15i plus 15i minus 25i squared. But really, we should just know it's the difference of two squares. So you're going to get 9 minus 25i squared. On top, you just distribute like we always do. Negative 6i plus 10i squared. Now we can simplify. I squared is negative 1. I squared is negative 1. And I get this. Negative 6i minus 10. On the bottom I have 9. Two negatives make a positive plus 25. So I get negative 6i minus 10 over 34. So you notice that has no I on the bottom because conjugate works. So anytime a binomial on the bottom, you have to multiply by the conjugate. So you just change the middle sign. So I cannot that's enough. That's what a conjugate is. If I give you 3 minus I, the conjugate is going to be 3 plus I. All you do is change that middle sign. That's it. Anyway, that's the answer. I actually should be able to simplify it. Divide everything by 2. Negative 3i minus 5 over 17. So that's how you multiply by a conjugate. Again, I care about the conjugate. So okay, let's wrap this up. Let's talk about how to solve equations. Now, if you remember what I said earlier in the previous video, if you have for quadratics, if you have one equation, one variable, just solve by isolation. Solve by iso. If you have two variables, something like x squared plus 3x, to 4, then you set equal to 0 and factor. All these are going to have one variable, so we're just going to solve by isolation. So I want to get the 4x squared by itself, because there's only one variable, so let's subtract the 32. 4x squared equals negative 32. Divide that by 4. X squared equals negative 8. Square root it. X equals square root of negative 8, plus or minus. Now remember, we can't leave this anymore. I know what the square root of negative 8 is now. Pull out the I. So I get I plus or minus rad 8. Even that, you should know how to break down 8. 2 times 4, square root of 4 is 2, so I should get plus or minus 2 rad 2. With an I forgot. So that's how that works. Right? Isolate it, you can get negatives. We're not scared of that anymore. This is an I. Pull the I out and then solve it like normal. Let's do these other two to make sure we got this. Right? This one, get this by itself. X squared equals negative 1, square root it. Don't forget the plus and minus. Anytime you square root, you should get a plus and minus. Square root of negative 1 is I. So there you go. X equals plus or minus I. Over here, try to get this by itself. Subtract the 50. Then we're going to divide by 2. X squared equals negative 25. Square root it. X equals plus and minus square root of negative 25, which is the same thing as just saying plus and minus 5i. Right? I comes out, square root of 25 is 5. So that's how you solve the imaginary numbers, right? Just solve it like normal. Again, if there's one variable, just isolate and solve. If there's two variables, set equal to 0 factor. Okay, very last thing. This is actually more of an SAT question I like to give you. So this is how I want to start this off. If I gave you 3x squared plus 2x minus 4, and I said that equals ax squared plus bx minus 4, and I asked you, hey, what is a? What you should say is a, since these two things equal, a is equal to the thing next to the x squared. So a has to be equal to 3. Since these two things are equal equations, the thing next to the x squared has to equal the thing next to the x squared. Same thing for the b. If I want to know what b is, it has to equal the thing next to this dx, the linear terms. Right? So if you have an equal equation, the two sides have to match. So the thing that's next to the x squared has to equal the thing next to the x squared. The thing next to the linear term equals the thing next to the linear term. The same thing happens here. If I have complex numbers, the real term, the 9, right, and there's no I there, has to be equal to the real term. What's the real term here? The thing without the I. So this. Because these are real. So the real thing piece has to equal the real piece. Likewise, the thing with the I, the imaginary piece, has to equal the imaginary piece. So 12i equals 4yi. And all you have to do here is divide. We're trying to solve for y, so divide by 4i. These cancel out, and you get 3 equals y. Divide by 3. X equals 3 also. So that's the way this works. If you have two things equal to each other, then they have to be equal to each other. So find the parts that should match. Right? This is all the imaginary part. That should match the imaginary part here. So 4b plus 2 should equal negative 6. I just dropped the i's, you don't need them. This is solving mathematics. Right? Divide by 4, you get that. Same thing. The real part should equal the real part. So again, 3a equals 9 again. A equals 3. So that's the way that works, right? When you have two things equal to each other, and you see this in SAT sometimes, they have to match. So the real parts have to equal the real parts, and the imaginary part has to equal the imaginary parts, just like up here. The x squared part has to equal the x squared part, so you could separate them and solve them. Is there anything less? That's just another example, so we're done.